This question is from GATE 2015, Mechanical Engineering paper, set 3, question number 32. Ratio of solidification time of a cylindrical casting of which height is equal to radius to that of a cubic casting of side 2 times the height of cylindrical casting is dash. Relation between the height and radius of cylindrical casting and the side of cubic casting is given here. We need to find out the ratio of their solidification time. Let's see how this will be done. We'll start by writing the given part. So it is given that height of the cylindrical casting is equal to its radius and therefore we can write its solidification time. Assume that solidification time for cylinder is TCYL is nothing but K into, where K is a constant for solidification time, V by A whole square. V here is the volume of casting and A is the surface area of casting through which the cooling is taking place. So for cylinder, we can write this as K into volume will be pi r square h. This is the volume of cylinder, pi r square area of the circle into h, the height, divided by surface area of cylindrical casting is given as the addition of curved surface area and the area of top and bottom circle. So we can write this as curved surface area is 2 pi rh plus areas of the two circles top and bottom are pi r square. So we can add them and write directly as 2 pi r square whole square. Now it's given h is equal to r. So after substituting it here, we get for cylindrical casting solidification time is k into pi h cube upon 2 pi h square plus 2 pi h square, which is nothing but 4 pi h square whole square. This gives us k into pi by pi is 1, h cube by h square is h. So it is h by 4 whole square. We have got this as the solidification time for cylinder. Now let's find what is it for cubic. Let that be TCU will be equal to again K into V by A whole square, but this time we have to take volume of cubic casting and surface area of the cubic casting. So solidification time of cubic casting is equal to K into volume will be side cube. Yeah, let the side of cubic casting be A. I forgot to mention that, sorry. And the relationship with R is given as A is 2 times the radius of the cylindrical casting. So we can write this is 2 times R and R and H are equal, so we can even write it as 2H. Coming back to this, solidification time for cubic casting is K into A cube by the surface area here is surface area of one surface is A square and there are 6 faces for a cube. So we have into 6 whole square of this, which is equal to, simplifying this, we have K into A cube by A square gives us A by 6 whole square. Now in order to relate these two and calculate their ratio, we need to substitute this relation that is given. So we have K into A is nothing but 2 times H by 6 whole square. This is equal to K into 2 by 6 is 1 by 3. So we have H by 3 whole square. Now calculating the ratio, we'll get TCYL by TCU. We have to calculate the ratio of solidification time for cylindrical casting to cubic casting. Don't make this mistake of taking the inverse. So it is TCYL by TCU, which is asked. Substituting from here, K by K will of course give us 1. So we'll directly substitute H by 4 whole square upon H by 3 whole square. Solving this, H square by H square is 1. We get 3 square upon 4 square, which is 9 by 16. And 9 by 16 amounts to 0.5625. This is the ratio for the two solidification times for respective castings. Let's go back and fill in the answer. Ratio of solidification time of cylindrical casting to that of the cubic casting as per the given relationship between their side, height and radius is 0.5625. To learn more about solidification time of casting, you can refer to the NPTEL video Freeze Wave Mechanism and Solidification Time from the course Principles of Casting Technology. This course is by Dr. Pradeep K. Jha. He is from Department of Mechanical and Industrial Engineering of IIT Roorkee. I hope this solution will help you clear your doubt. Thank you.